Alright, hello and welcome back. This is problem number 15 from a Physics C AP multiple choice, Physics C Mechanics AP multiple choice test. So this is the second in a series of 3 problems related to this scenario above. A ball of mass 2 kilograms is thrown vertically upwards from the top of a building. The ball's velocity v is given as a function of time t by the equation v of t is equal to r minus st, where r equals 5 meters per second and s is equal to 10 meters per second squared. The positive direction in this case is defined as upwards. And question 15 asks us, at what time does the ball reach its maximum height above the building? So another projectile motion problem. This one has a quick little trick to it. So let's draw a little diagram to start off with. Yeah. So it's launched from the top of the building, right? So here we've got our building and the projectile is thrown upwards and then it comes and it hits the ground. And we want to find when it reaches its max height. So that's going to be here. We don't know where that is, but that's where it's going to be. And the answers to this are, let's write these in. Um, 0.2, 0.4. Alright, A gives us 0.2 seconds, B 0.4, C 0.5, D is 1.0 seconds, and E is 2. So these are our options to choose from. Alright, so we have our equation for velocity that we found in the last video where we really just plugged these numbers in, very simple. So let's do that again. V of t is equal to r is 5, substitute that in. S is 10, substitute that in. T. Here's our velocity equation. So, we know that when the ball reaches its maximum height, throughout this, obviously the ball is deaccelerating, as we found in the last problem, by the rate of gravity. So at its highest point, it actually does not have velocity. Its velocity is 0. It's like it still has x velocity, but there's the initial x velocity stays constant, but the y velocity, since it's been deaccelerating, it was positive, and now it's about to become negative, it hits 0. So for that moment, we know that we're going to be setting this equal to 0, because at that point, our velocity is 0. So once you do that, this makes us a pretty simple problem to solve. Let's subtract 5 from each side, and again, we're isolating t because we're looking for the time. So negative 5 is equal to negative 10t. Let's divide by negative 10. Alright, negative 5 over negative 10 is positive 1/2 is equal to t. Alright, C, 0.5 seconds. So it's a very simple problem, but the trick to this one is knowing that at the top of a projectile's flight, it has a vertical, a y velocity of 0, because at that moment it's been deaccelerating, and it just for an instant it isn't moving up or down. It's just there, it rises, it's there, and then it keeps going down. But for that moment, it does not have y velocity. Because we know that, we can set the equation for velocity equal to 0 and solve for the t at which the velocity is 0. That tells us at what time the ball reaches its maximum height. Pretty straightforward. Let me know if you have any questions about this one. Drop your comments below, questions, concerns, thoughts, anything on these videos. And again, thank you for watching. My next video is going to be question 16 from the same test, the last in this little series we have relating to this scenario. So make sure to check back soon to watch that one. Thanks for watching.